4.5, modeling with algebra. Now, when we're looking with modeling with algebra, it's really problem solving that we're trying to do. And there's a lot of words that represent certain mathematical operations. For example, addition. Some of the words that you might see in a word problem include the words plus, more than, greater than, total, sum, older than, consecutive, and increased by. All of these words represent some sort of addition is happening. So when you're looking for, when you see these words, you know you've added something in order to get these values. Next word, subtraction. Subtraction can have the words such as minus, less, less than, fewer than, difference, decrease by, and so on. So these are only some of the words. And notice I added the word and up here because addition will say, for example, let's say the oranges and the apples together cost a certain amount. So you would have to add in order to have addition. Subtraction, this minus, less, less than, fewer than, difference, and decrease by, all imply that some sort of subtraction was going on with the statement. Multiplication. Multiplication of, times, multiplied by, twice, triple, double, product of, by a factor of. All of these imply there's some sort of multiplication. This particular statement you'll see in later grades will use this to describe transformations that happen. But these ones here are also quite important when we're looking at word problems that involve multiplication. Division. We'll have per, in, out of, ratio of, into, quotient of, percent. Now, some of these you may already know. For example, percent is per means out of or divided by, and then cent in French is 100. So percent is always you're taking the number that says, let's say you're given 50%, means 50 out of 100. And all of these also refer to division. Finally, equals. Equals, it's funny though, sometimes when you look at the word equals and it says, really, there are words that imply equals? Of course there is, are, was, were. So some sort of total was implied. Will be, gives, yields, sold for, has a total of, a total value. So here, folks, are words that imply equals. Now, when we have word problems that have these words in them, we need to be able to solve word problems by following certain set of steps. For example, steps to solve word problems include the following. Write a let statement. Because the question starts with words, we actually start our problem with words. That is, a let statement to represent the variable. So we let X represent is the statement that we want to start off with whenever we have a word problem. Part 2. Write a mathematical equation to represent the problem that we're trying to solve. So you need to write some sort of mathematical equation, and in that equation we will have an X somewhere in that equation. Next, we solve the equation for the variable. Now, you can check your answer to make sure it matches. And finally, don't forget, write a therefore statement. So we write the 3 dots instead of the word therefore, and this is a statement that we make at the end of the word problem in order to conclude our problem. I.e., we start our equation with words, our word problem with words, we end with words. And that's important to note, folks, because when we solve for the answer, solve for the equation, there's no words involved. it doesn't apply anything. But when we write the therefore statement, we're reattaching the words that we started with the number that we found when we used the equation. All right, moving on. Example 1. The sum of 3 consecutive integers is 105. Find the numbers. So, this is all you're given. So we need to read this and figure out what it's asking. For example, what does consecutive mean? Well, when you think about it, the numbers 1, 2, 3, 4 are all consecutive. So, if we let x represent the first number, okay, in our order, the next number will be, that's right, I hope you're thinking, that the next number will be x plus 1. And the number after that will be the next number, x plus 2. And we're going to follow through this. So x is your first number. Our next number after that is the original x plus 1 is the next number. And then the next number after that will be x plus 1, which is x plus 2. So we're going to add all these. The reason why we're adding them is the word sum tells us to add all the consecutive integers. So we do that and we get x plus 1 plus x plus 2, and that has to equal, because there's the word is, which means equals 105. 105. So again, the first number plus the second number plus the third number equals 105. So we collect like terms. That is, we put all the x's on one side and then we put the numbers on the other. So we have 105 and we have to subtract 1 and we have to subtract 2. So we're taking 105, subtract 1, subtract 2, and we get x plus x is 3x. So this is the x plus the x plus the x, which is 3x. And then 105 minus 1 minus 2 is 102. So we have 3x is equal to 102. Divide. Hopefully you're thinking, okay, we need to divide both sides by 3. Once we divide both sides by 3, we get x equals 34. So what does that mean? Well, our first number is 34. Now, you can tell you did something wrong when, for example, if you were to do this and you got a decimal answer. Because of the way the question is stated, it's an integer. Integer means that the number cannot be negative. Okay? Can be negative, but can't be a decimal. So we can't have a decimal, for example, as our answer, or a fraction, because we need the number to be an integer. All right? So we can check x equals 34 in the equation. So how do we do a check? Let me show you. So you have a left side and you have a right side. This left side and right side separates this equal sign. So this equal sign creates a line. It's like a border. And this is the left side of the equal sign and this is the right side of the equal sign. So we restate the equation and separate it by left side and right side. Now that we have separated them, we can now substitute the x with the number 34. So every time we see an x, we're going to replace it with 34. 34 plus 34 plus 1 plus 34 plus 2. And now we add these all up. 34 plus 34 is 68. This is 69. This is 70 and 71. Add the 4 is 75. 75 plus 30 is 105. So this is 105 is the left side. 105 is the right side. What does that tell us? What do you see? Do you see what I see here, folks? Oh, yes, I hope you do. That's right. Left side equals right side. We have checked that it's equal, and that has made us, that's right, happy. So we can finish our equation, our problem, by making a therefore statement. Therefore, the numbers are, well, the first number is 34. What will the next number be? Remember? That's right, 34 plus 1, which is 35. And then 34 plus 2, which is 36. So these are the consecutive numbers. 34 plus 35 plus 36 will give us 105. All right, well, that's example number 1. Moving on. Example number 2. Mike is 7 years older than Isla. The sum of their ages is 29. How old are they? All right, so this question, what we're looking at, is being able to develop a problem for this. We need to let x represent something. In this case, what we're going to do is let x represent Isla's age. All right, so we have Isla's age that we're going to let x represent. Now, the problem says Mike is 7 years older than Isla. The sum of their ages is 29. How old are they? So we have x represent Isla's age. So we have Isla plus Mike will be what? So we have Isla, who is x. X is Isla's age, plus Mike's age. And Mike is 7 years older than Isla. That means Isla is x plus 7 to make Mike's age. And the total of all of their ages, and the sum of their ages, is 29. So we've now developed our equation. Now, folks, you don't have to write this part out. This is to remind you of how we get these parts of the equation from. Isla plus Mike, this is the total for Mike, is equal to 29. So now what we have to do is solve. X plus x is equal to 29 minus 7. 2x is equal to 22. X is equal to 11. So what we have to do now that we have x equals 11, we're going to check. What are we going to check? We check x equals 11 in the equation, x in the equation. Now, instead of writing the whole equation out, because we're going to do it in the left side, right side, I will let you write EQ apostrophe N, which means equation. So, separate the equal sign with a line, and what's on the left side will be x plus 7, and on the right-hand side, we will have 29. So, EQ apostrophe N, again, one more time, means equation, and the right-hand side will be 29. We replace x with the value that we found, which is 11. So 11 plus 7 is 11 plus 11 is 22, plus 7 is 29. Do you see what I see, folks? I hope you do, because that's right. Left side equals right side. We have checked that it's equal, and that's made us happy. Okay, moving on to our final statement, which will be, therefore, because we need to know how old they are, we can say that Isla is 11 years old, because that's our x value, and Mike is how old? Well, Isla's 11, so Mike was 11 plus 7, and Mike's age is 18 years old. And that, folks, is our final statement. Moving on, another word problem. Sheila works at a ballpark selling peanuts. She is paid $14 per hour plus a 50-cent commission for every box she sells. What will she earn if she sells 42 bags of peanuts in 5 hours? Well, we need to have, again, this is a word problem, So let's start off with a let statement. Let X represent Sheila's earnings, because that's what we don't know. We know that she makes $14 per hour with a 50-cent commission for every bag she sells. We know that she's worked 5 hours, and we know she sold 42 bags of peanuts. What we don't know is her total earnings. So X is her earnings. Now, how much does she make? She makes $14 every hour, so times 5, plus she sells for 50 cents. She makes a profit, so commission is how much you make for selling that product. And oftentimes, for example, sales jobs and real estate and car dealerships, those are all jobs that involve earning some sort of commission. You have to push your product to make a little bit of extra cash. So 50 cents for every bag she sells. Well, she sold 42 bags, and that's what we need to solve. So 14 times 5 plus 50 cents times 42. And we will find out so earnings is X, and we will just go through each piece so you understand how we got each piece. She makes $14 per hour. The 5 represents how many hours she worked. Okay, so 5 hours that she worked. And then the 50 cents represents commission per bag, so commission rate of 50 cents per bag. And 42 represents the number of bags sold. All right, so this is how all the equation came by. You do not have to explain where this equation came from, unless the question asks for it. But here what I'm showing you is how each part came to fruition based on what was read up here. Now, we need to solve. X equals 70 plus 21. X equals $91. Therefore, so our therefore statement, Sheila earned $91 in 5 hours. Now, if you wanted to do a therefore, you can. Statement, if you can. A therefore statement is a requirement. So this is the minimum amount that I would expect in blue to be able to solve a word problem. The only time you need to do a check is if you're asked to do a check or you want to do one because you have some extra time and you want to check that your answer makes sense. Now, what wouldn't make sense if you had a strange decimal going on, folks? If you had a strange decimal, you probably made a mistake. So note that in here, when we're talking about money, $91, the most it can round to is 2 decimal places. And folks, based on this equation, the only decimal you could have possibly had, if it was a problem, would be like a 50 cents. Because remember, she earns 50 cents for every bag she sells. Let's look at another problem and how we can readjust this problem. So we're going to keep Sheila the way she is, but we're going to change our A to be B now. Let's look at another example of how we can manipulate this Sheila question. Part B. How many bags of peanuts must she sell to earn $100 in 7 hours? Now this, folks, again, is the same Sheila problem as before, but now we're asked how many bags of peanuts must she sell if she has to earn a specific amount. So our let X statement changes. That is, let X represent the number of peanuts sold. So we know she made $100, and we know she has to make that $100. We also know she made $14 for selling these bags of peanuts for 7 hours. So 14 times 7. Next, what we need to do is find out how many bags she sold in those 7 hours. Well, that's the part we don't know. So 50 cents we know she makes per bag, and then X is the number of peanuts sold. So 100 is equal to 14 times 7 plus 50 cents for every X. So for every bag of peanuts sold. So this is where our X is this time, because it represents the number of peanuts sold. So we can solve this problem by 100 equals 14 times 7 is 98 plus 50 cents for every x. Next, what we want to do is keep this 50 cents here, and we're going to move the 98 over. And remember that the operation in front of here is a plus, folks. Okay, plus 98 plus this. So this plus that's here moves the 98 over, becomes minus. 100 minus 98 is equal to 50 cents x. Now 100 minus 98 is 2, which is equal to 50 cents x. What we're going to now do is get x by itself. So we have to unattach this 50 cents by dividing. So we're going to divide both sides by 50 cents. And we get, that's right, x is equal to 4. So in the 7 hours that she worked, she only sold 4 bags of peanuts. Or she has to sell 4 bags in order to make the $100. So we make our therefore statement. Therefore, Sheila must sell 4 bags of peanuts in 7 hours to make her $100. And that, folks, is the end of the word problems. Well, that's the end of all the examples I have. Have a numerical day.